Hello everyone. Today I want to show you how to left shift your SLOs. A little bit about myself. I'm Michael. I'm working at GitLab as a developer evangelist, and you can find me online as DNS Michi, which is DNS MICHI, on Twitter, on LinkedIn, and everywhere else. Now let's dive into a little bit of history when we have been slowless. Meaning to say, well, we're turning back time a little and saying, well, we had the traditional monitoring, state black box monitoring, slowly have been adding metrics to our monitoring journey. We had traditional SLA reporting at some point, probably generating some PDFs for our managers and also calculating the service level availability for our customers. So we were tracking state changes over time, maybe adding some metric data points and trends. And in the end, we kind of needed to learn SLA, SLO, and SLI. And that's it. Let's dive a little more into the history and find some situations where it could have been useful to develop some rocket science and also add SLOs. Let's start first with a story of the past of mine and say, well, we're building software as developers. We had a slow REST and JSON RPC API. And the responses didn't really turn out to be good in large-scale environments. We were thinking about a CPU overload with threads involved and considered using lightweight coroutines in C++, meaning to say those are like fibers or asynchronous routines, stackless. The function pointer is put on the heap when the function is being paused, and the stack unwinding happens then for continuation. Sounds easy, and we continued implementing that. Well, and then we had to debug it because it went in production, it went into release, and there was a certain crash in production only, but only with having 1,000 API clients and a little more than that. The memory was corrupted at some point, and it also sort of was exhausted, which pointed to some sort of leaks. And we were not sure about it, and lots of time went into debugging this cause, when we could have created a staging environment and defined our SLOs, because we actually want to ensure that the stack and heap memory meets the operational requirements. So defining the service level objective of saying, hey, we want to ensure that heap and stack memory is on the usage level we define, for example, 2 gigabytes of RAM, because we cannot really exceed that from an agent perspective. And the other side was we actually needed to measure that in real-time production environments. It works on my machine. It's not a valid argument when the application is crashing. And also we probably would have needed sort of chaos engineering for our API requests. Everything was not there, and this is just one of the many things where SLOs would have been helpful. Another story is when it goes really slow. You maybe remember the time when there was a report about the GTA Online, and the loading times were like 8 minutes or 10 minutes, and the user reverse engineered the source code, guessing from the assembler code how often a specific function is being called, and reverse engineered that in a way of creating a preload DLL and saving 70% of time. Now, well, it could have been prevented in our development process. So the mitigation as a developer would have been like measure the login time at application timing points. In the first iteration, add some metrics. In the second iteration, look into tracing spans and just figure out what's going on and make the application useful. The thing is, we still need to add some sort of service level objective to achieve. And this is now SLO in a staging environment. We want to ensure that merge requests and pull requests are directly deployed from a CI/CD pipeline into a staging production environment. And we're defining end-to-end test scopes, saying, well, it is the user now doing the login. This is one of the test scopes. And then the user is playing and also experiencing some like logout, login issues and so on. For defining an actual SLO, let's just imagine saying, hey, the login time needs to be lower than 2 minutes. But for low latency connections, for example, a metric which we can correlate from application performance monitoring and user monitoring in a certain way, if it's a low latency connection, we want to increase the login time to 5 minutes because there could be traffic involved and other things. And when we detect a certain failure of the SLO, we have a quality gate, the CI/CD pipeline fails, and the release is never being released actually. And we can actually fix the problem early enough, and the user and the customer doesn't see it. This brings me to defining an SLO process. So in order to shift left, we need to update our culture, we need to update our workflows, we need to define an actual process for that. Meaning to say, we need to be aware of quality gates in our CI/CD pipelines. So for example, we can use Captain as a quality gate. We can combine it with Prometheus for metrics, measuring the SLOs. But we could also add chaos engineering, like adding Litmus chaos to it. In addition to quality gates, we also need to define application observability, like adding the traditional application performance monitoring, and enriching it with logs and tracing and combining everything into OpenTelemetry. So our SLOs are actually defined early enough in the CI/CD pipelines with quality gates, with application observability. Now, when we want to measure everything, we certainly need to find ways to automate things. So probably defining an SLO means we generate it from a predefined DSL. And I would recommend watching Andrew's talk around this, how we define it on gitlab.com, and matching several things, even about Simpson SLI. In order to go slow, and this brings me to basically summarizing what I've learned in my past, developers need to get the SLO feedback. So it doesn't help when someone is paged or someone watches a graph. It needs to be there. So directly integrated into a merge request or pull request, you need to get the details, why the pipeline was failing, what exactly is the SLO, and more details to read upon, and of course training the teams to adopt it. So we could have prevented of introducing coroutines because the memory is corrupted, would have never reached customers in large-scale environments. The GTR online login algorithm would never have been introduced in that way. And of course, we would have added more code quality checks. This is everything we can do for improving SLOs. And in order to go even more slow, we really want to correlate the SLOs with our instrumentation and observability capabilities in the future of our DevSecOps workflows. We need to train everyone and make everyone aware that this is a benefit, and also make use of the dynamic resource environments, because this is a huge benefit of auto-scaling virtual machines in AWS, in whatever cloud is needed. And we can also reuse the power of container clusters and add chaos engineering. Say, well, I want to really battle test the application before it reaches production. And there was once a SLO that put to prod. In order to do that, I would recommend checking out Captain and Prometheus, Litmus, and a little bit of continuous profiling in the next steps. Thanks for your attention. Now I'm really looking forward to your questions.